Let's discuss a question on theory of machine. What is given as a shape return mechanism. Now let's draw this shape return mechanism when it looks in the extreme position. So in the extreme position, this is O and this is my crank S. The crank makes an angle 90 in the extreme position in the sense when this PS changes the direction. Okay, so now remember that when this OS moves clockwise between these extreme positions, now these are your extreme positions of PS, of the link PS. Okay, this is PS, you can call it PS2 and you can call it PS1. So when the crank rotates clockwise between these extreme positions, the PS2 moves anti-clockwise and it moves along with the in the direction of crank, and the block basically returns. Like if you imagine that OS moving clockwise, the PS2 moves in this direction anti-clockwise, takes the position PS1 as OS moves clockwise, and the crank returns. So this is in this part of the thing I call this angle as theta r, because the block basically returns, and in the when the crank moves from OS1 to OS2, the slider moves in the forward direction, so this is theta f. The return ratio is determined in the sense that theta r by theta f is the quick return ratio, which is given as 1/2. Remember that theta r, theta f are the angles at one point and they cover the entire space, so that is 360. Theta r plus theta f has to be 60. Going by this, we can say that 3 theta r is 360 using 1 in 2, and theta r is 120 from this. So looking at the extreme position, theta r is the total angle between extreme position, and because of the symmetricity this angle is half, and this is 90 at the extreme position. So OP is given as 500 mm. Now in this right angle triangle, if we use trigonometry, cos 60 is adjacent side, so I'll use cos, so I need the adjacent side OS by OP. Cos 60 is half, OS is something which I need to know. OP is given as 500 mm, so OS comes out to be 500 by 2, it's 250 mm. So 250 mm is the answer. So the basic thing is, from quick return you can get the angle, and from the angle we can get the anything, okay, all the lengths. Thank you.